Welcome back to BLOCKTV. It's time now for links in the chain. And when it comes to Bitcoin, the technology is by no means in its final form, constantly being worked on by developers to streamline and alter the potential for the underlying tech and how we interact with it. Andrew Poelstra, who currently works as Blockstream Director of Research, is one of the most recognized Bitcoin developers in the community, and he joins us today on BLOCKTV. Andrew, thanks so much for being with us.
Hey, happy to be here.
All right, so Andrew, back in August, you announced the development of what you call your Miniscript project. Tell a little bit to audience and those who are less technically minded what that means and what implications that has for the Bitcoin network as a whole.
Sure. So Bitcoin, something that not a lot of people know about Bitcoin is that since its inception, it's supported fairly complex, I guess you could call them smart contracts. Different ways of encoding spending conditions for coins. It's possible not only to have coins controlled by an address the way that we're used to, where an address corresponds to some sort of public key. The person who has a secret key in their wallet is able to spend the coins and nobody else can spend the coins. This is sort of the classic model of Bitcoin that we're used to. But you can do much more involved things. You can do threshold signatures, you can do multi-signatures. So for example, you could have 3 participants. Any 2 of them are able to spend the coins together. You don't need all 3, and just 1 is not sufficient. You can also do things like Lightning payment channels, where you string together various secrets and secret revelations in ways that ensure that different transactions are atomic. And then another thing you can do is set up certain spending conditions, such as they're gated by time locks. By timing conditions. So you can say, for example, that for the first 2 weeks of a coin's life, then it's controlled by some threshold. It's 2 of 3, like a 2 of 3 policy. But then after 2 weeks, if the coins haven't moved, maybe you assume that that the signers who were supposed to be in control of the coins actually lost their keys, or they're unavailable, or something's gone wrong. And so you can have an alternate policy. You could have some emergency signer or some cold keys or something like that, which would then be usable, but only after the 2-week delay. So you have some emergency signer. You don't want to trust them unless everything goes wrong, basically. So you gate the ability for them to spend behind this timeline. So this is something, everything I just described are things that Bitcoin has supported for the last, I guess, 10, 11 years now. But not in a particularly accessible fashion. The way that you would implement such a policy is by using a technology called Miniscript, which is a very rudimentary, a very low-level programming language that allows you to describe these conditions in terms of very basic, very primitive operations on just blobs of data. And the important thing here is that Miniscript doesn't really understand that you're talking about signatures, and you're talking about secrets, and you're talking about time locks, and you're talking about numbers, and so on. It's sort of manipulating blobs of data in a very simple way. And your object as a programmer in this language is to somehow encode a high-level policy, like I want these coins controlled by 3 participants, except after 2 weeks, it's a different participant. You're trying to encode a high-level policy like that in this very low-level language. So what Miniscript gives you is a higher-level language. It's a language where you directly encode these spending conditions. So in Miniscript, rather than saying, assume you have a signature, move the signature to this part of the stack, assume you have a public key, rearrange these in such a way, check a signature. If the signature passes, push a 1, otherwise push a 0. Like, this is what Bitcoin script looks like. It's very difficult to map these kind of low-level operations to something meaningful. But Miniscript lets you directly encode these, your spending conditions. It lets you say, here's a set of keys. You need this many of these keys to sign. Alternately, here's a time lock. You need these keys if the time lock is satisfied. Alternately, here is, say, a hash, like a secret that somebody needs to reveal. And if somebody reveals the secret, then they're allowed to use this yet alternate set of keys, or something like that. And these different ways of spending coins ultimately are how things such as the Lightning Network are constructed. It's how split custody wallets such as Blockstream Green or BitCo are constructed. It's how a lot of long-term cold storage solutions are constructed, where you have some set of keys, some hot keys that are actively online and you expect people to use, and then you have cold keys that become active later. All these different uses of Bitcoin are ultimately encoded as different sets of spending conditions. And Miniscript lets you write down those conditions directly rather than reinterpreting them as script operations. So it'll make a lot of what people are doing today in Bitcoin a lot easier and a lot more robust.
Now, you say they will make the possibilities easier and make it more robust, but what is the state of Miniscripts as it stands right now? Are they being utilized daily on the network? Is this still an ongoing process? Where do you sort of see the state of the project as it stands?
So one very cool thing about Miniscript that differs from pretty much all the other research that we see today is that Miniscript is already deployed on the Bitcoin blockchain. So Miniscript actually does not require any changes to Bitcoin. What Miniscript is a different way, on the technology level, it's just a different way of interpreting the Bitcoin scripts that already exist. So the most common scripts out there that people are using, for example, Blockstream's Green, Blockstream's Liquid, BitGo, Lightning, atomic swaps, decentralized exchanges, all of these different things that people are building on Bitcoin. These all use scripts that either are mini scripts or they could be tweaked in very minor, very inconsequential ways to be mini scripts. So right now on the blockchain, technically, I guess the majority of coins are controlled by mini scripts. They're controlled by one of the simplest possible mini scripts, where you just have a single public key and you require a single signature from a single participant. But even some of the more interesting applications of Bitcoin script are actually mini scripts. So for people who want to switch from using script to using mini script, they can literally take their deployed system. They can take the scripts that they're already using and the code that they've already written to handle these scripts, and they can simply run this through the Miniscript library, through the Miniscript software, and it will reinterpret that as a Miniscript. It will give a human-readable representation of the script. It will automatically answer all sorts of difficult questions that you need to answer about these things, like how much will this cost me? How large will a transaction be if I spend these? How can I estimate fees? How can I determine which signatures are needed? How can I determine which public keys are active? How can I determine which time locks are around? All of these questions that you need to answer to work with Bitcoin script, but which Bitcoin script makes difficult to answer because you have to encode things in this awkward way.
So I suppose I wonder as well, I mean, criticism comes up from time to time about the concept of using smart contracts or something approaching smart contracts on the Bitcoin network, as people say that it wasn't necessarily designed for that sort of use, and that, as you say, the scripting language that existed in the past was really not functionally accessible for humans. It was quite difficult to work with, and that better to leave those sort of operability issues for Ethereum, for EOS, and for scripting languages that are more purposely built for that sort of idea and concept. Well, how would you answer criticisms on that and regarding this particular issue?
So there are a few things people mean when they talk about Bitcoin not being designed for smart contracts, or when they talk about smart contracts being bad for Bitcoin. One worry people have when they talk about this is they don't want Bitcoin to become an Ethereum-style data store, where the way that Ethereum contracts work is every single contract contains a big pile of data. Every time you create a transaction in Ethereum, you're able to manipulate the data associated to that contract. And so for validators of the chain, they have a tremendous amount of validation costs. They have a lot of random disk accesses. It becomes much more difficult to verify. It's much more difficult to verify Ethereum transactions than it is to verify Bitcoin transactions because you have all of these random disk access. Another thing that storing data on the disk causes is, or one thing that it enables that people are worried about on Bitcoin, is the ability to store arbitrary non-financial data on the blockchain. And this is something that worries people because the idea behind a blockchain is that you have some set of space in your blocks. This space should be used by transactions. This space is very expensive. In order to get more of this space, you need miners churning away doing this proof of work and getting these block rewards, which are paid for in terms of transaction fees and in terms of block subsidy. And the worry is that if people are using the blockchain for non-financial things, just for trying to timestamp things, or for trying to publish things, or for trying to use it as a communication layer, then the incentives behind the network fees will become uncoupled from the incentives miners have to continue lengthening the longest chain. Having said all of that, Miniscript doesn't cause any of these concerns for two reasons. One is simply that Miniscript doesn't introduce anything to Bitcoin that doesn't already exist. It's purely a way of making the existing functionality in Bitcoin more accessible. But then another reason is that by design, Miniscript is designed to encode spending conditions. It can basically do three things. It can check for time locks. It can check that some period of time has passed. It can check either that an amount of time has passed or that a date has passed. It can look for signatures with specific public keys belonging to different signers, different participants in the transaction. It can also request that secrets are revealed. And then what Miniscript gives you on top of that is just the ability to combine these in arbitrary ways. So what Miniscript enables in terms of smart contracts are directly the things that you need to use to control how coins are spent. It directly enables different financial applications without giving you fully general abilities that could be used for non-financial applications. So I think people who are concerned about introducing smart contracts to Bitcoin, about extending the scope of Bitcoin beyond what's reasonable, or about decoupling incentives, Miniscript does not give those people any reason to be concerned.
It sounds like there's a wealth of very useful and functional applications that can be applied to the Miniscript technology. As it stands now, you say it's already being functionally deployed throughout so much of the network, but looking forward, are there any additional projects, either with Miniscript or other development projects that you're working on that our viewers might want to hear about?
Sure. So one of the promises of Miniscript is that you would be able to do different forms of analysis on your contracts, on your spending conditions. So for example, you could imagine a company like BitGo or like Blockstream Director who is acting as a countersigner to its customers. So the way these work is you have multiple keys being used. You have one key belongs to the user, another key belongs to Blockstream, and after some amount of time, then using a time lock, the coins then become controlled entirely by the user. So it's just for a short period of time that Blockstream and the user have joint custody. And this gives the user the benefits of having self-custody. Certainly Blockstream doesn't hold the coins, Blockstream can't run away with them, while also having the benefit that they aren't entirely dependent on their own security for the security of their coins. But in order to do this right now, the functionality of Blockstream Director is limited specifically to the one user, one countersigner setup. And it would be cool in future if the user could show up with some arbitrary complicated contract. Say, we would like a countersigner, and Blockstream would be able to simply look at this contract, say, I can count through all of the different spending conditions here and verify that every one of these spending conditions involves a Blockstream signature. Therefore, I am a countersigner. I will accept this. You can use this in Blockstream Green. So the distinction here is between having a fixed policy that the software supports, that you can't really go beyond without Blockstream needing to update the software for every specific case, to going to a situation where the user can do pretty much whatever they would have been doing with Bitcoin, and then they have the ability to add Blockstream as a countersigner. And so this is something that in principle should be very straightforward to do with Miniscript, because we're directly encoding the spending conditions. We can just iterate through them, check each one, but there's a fair bit of software development and a fair bit of engineering work that needs to go into that. And that's what I've been spending my time working on over these last few weeks, and what I'll be excited when this is finally ready to deploy.
It certainly sounds like there's some exciting things coming in the future. So much development, still important work to be done in the Bitcoin world. Luckily, we have developers such as yourself, Andrew, taking on that mission. So Andrew Poelstra, I want to thank you so much for coming on BLOCKTV and chatting with us to talk us through some of these technical developments that are happening in the Bitcoin network. Thanks so much, Andrew, for being with us, and stay with us at blocktv.com for all the latest in news and information. I'm Asher Westrop Evans. Thanks for watching.
For more news and updates, follow us on Twitter.